This is the first video in a series that will show you how to implement camming into a PLC Open project with the KAS IDE software. Before we go ahead and add function blocks into our PLC code, we have to create a cam profile. We're going to show you how to use the tool inside the KAS IDE to either import or create new cam profiles using our graphical editor, where you can specify user units for both master and slave axes and add new points and place them wherever desired. I'm starting with a new project in the KAS IDE software. If you want to add a cam profile that you create ahead of time or before you compile and download your project to the controller, you do it through the Profile section of the Project Explorer. We do have the ability to create cam profiles and modify them inside PLC code, but that's more advanced features that will be covered at a different time. For now, on the Profile section, you can right-click to either create a new profile, or you can also import them from CSV files if you've created it through another program like Excel or MathCAD. For now, I'm going to right-click and create a new profile. It will give it a default name, which you can right-click and rename if you choose, or you can double-click it to open it up in the main window. When you add a new cam profile, you automatically start with this base 5-point out and back cam. You can change through two ways. On the left, there's a spreadsheet view where you can choose any point's master or in point, slave or output point, or the instantaneous velocity and acceleration at that point, and directly type in with your keyboard if you'd want to change any of these parameters. You can also use your mouse on the graphical top right section, drag and drop any point, and also once a point is selected, you also get the option to grab through the dashed line and slide up or down, which will change the instantaneous velocity at that point. If you make changes in any way, it'll automatically be reflected in the spreadsheet or in the graph and vice versa. You can also add or delete points through either way. Either when you have one selected, you can hit the plus to add a new point, or minus to remove a point from the spreadsheet view, or through a right-click menu you can insert points, or when a point is selected you can hit delete and your right-click to delete through the graphical portion. Also, in the bottom you will see that we're automatically graphing the velocity, acceleration, and jerk that the slave axis will go throughout the current cam profile on the top. The top is all position based, so the x-axis is showing the master or input points, and the y-axis is showing the slave or output points. So in this instance, when the master is at 100, the slave will be at position around 315. Now as you go through, the master goes from 0 to 360. On the bottom, we automatically plot what the slave's velocity, acceleration, and jerk is, but also notice that they are unitless because this will all depend on how fast the master is going. That means if I'm just plot the velocity, at this point, when the master is at about 60, the slave will be going 2 times as fast as the master. You also have the option to change the type of cam profile segment you have. So between any two consecutive points, the default is to have a point type which has a 5th order polynomial that limits jerk to a smooth motion between the two consecutive points. Sometimes you don't want to have any acceleration between 2 points though. You just want to have constant velocity. Maybe you want to match speed with another segment of your machine. Maybe you're doing some cutting or printing, labeling. So you can change from point type to line type. When you do that, instead of having the 5th order jerk limiting polynomial, it will have a straight line with no acceleration and constant velocity in that segment, even if you move the point before or after around. You also see the cyclic checkbox. That just means that the beginning and end point will have the same instantaneous velocity and acceleration. If you change it on one side, it will force it on the other, so that the cam profile can repeat over and over again if the master axis continues to rotate in one direction. You don't have to have this. You can have the cam start and end at different points with different velocity accelerations. You just have to uncheck that option. So sometimes you'll have a repeating cam where the slave axis will start and end at the same spot. You don't have to have that. You can also have a slave axis continue on in one direction. So in this example, for every rev of the master, the slave will also move one rev, although it won't go a constant velocity. It will go out, back a bit, and then continue on to make one full revolution. Finally, when creating a cam profile, you can pick the user units and the width, scale, of both the master and slave axes. When I create a new cam profile, it uses default units of degrees, but also only lets you use one revolution for both master and slave. But you can change that. So if I right-click the cam profile under the Profile section of the Project Explorer and choose Properties, it will bring up Input or Master, which is, remember, the X portion of the cam profile, and the Slave or Output, Offsets and Scales, which will adjust the Y-axis of the cam profile. So the scale, these will be the units. Oh, this will be the width of each. So right now it's 360, so then I have going from 0 to 360 on the x-axis. I'm going to change that, so maybe I want to go specify how far the slave moves over 2 revs of the master instead of 1. So I'll change it, so now it's 720. Maybe I want to change the units though for my slave or output scale. Maybe instead of having a rotary axis, I have some linear mechanics that will go between 0 and 10 inches or 10 centimeters. So I can change that to 10. If I press OK, the cam profile maintains the same shape, but it automatically changed both X and Y axis. Now my master input scale goes from 0 to 720 because I changed the range instead of to 360 to 720. So now I specify how the slave moves over 2 revs of the master, and also my slave points or y-axis go between 0 and 10 because I changed that from being in degrees to different user units. You can also go back to the Properties menu, change the offset. So this will determine where you start. They both defaulted at 0. Maybe you don't want to start at 0. So I'm going back to my example of the slave or output. Maybe I have some mechanics on it, linear mechanics, but instead of going between 0 and 10 inches, I want to go between -5 and 5. I still keep my scale, so this is the overall length or height of the y-axis, but where you start is the offset. So instead of starting at 0, I want to start at -5. If I press OK, my total width now is still 10, but instead of starting at 0, it starts at -5. So now all my slave or output points are between -5 and 5. And those are all the steps you need to create a new cam profile within the KAS IDE software using the cam creation editor tools we have. In the next video, we're going to show you how to add PLC functions into your code in order to implement a master-slave cam relationship into your project.